Hello grade 12, welcome to my channel. Let us have a look at the arithmetic series. Okay, so we saw what an arithmetic sequence resembles, and we took it a notch further. We saw what a quadratic sequence looks like, and we took it yet another notch further to see what a cubic sequence would look like. Although that is not part of our syllabus at the moment, but that's something to think about, so that even if a quartic sequence was given, one would essentially know how to go about it using the basics, building from a linear to quadratic to cubic, then to quartic, and then quintic. You know, you name them, you go on and on. Okay, so we saw that from the definitions we gave in the previous video, that a series is nothing but the sum of the terms in a sequence. Now, if this is an arithmetic sequence, it means this is the sum of the terms of a linear pattern, right? So how would we add these? Obviously, when the sequence is this short, it's as easy as to say, well, the arithmetic series is essentially equal to, maybe let's put it here, and say if this is all we are adding, so we just simply punch these into the calculator: 3 plus 5 plus 7 plus 9, and we get our answer, which is 24. But now the problem would come when we have to handle a sequence much larger than this, because we can't just put every individual term into the calculator for a very long series. So this is easy when it is like this. But now let me show you another technique of dealing with this sequence smartly. We can easily say, well, our arithmetic series could have been looked at as essentially 3 plus 5 plus, maybe let me use different colors. So we could have had 3, 5, 7, 9. And what if we decide to add the arithmetic series in reverse? Say 9 plus 7 plus 5 plus 3. This is still the same series, but we just decided to write it in reverse. So what do we get? Now AS plus AS, we're going to get 2AS. Now guys, in maths we need to be very smart, right? We need to. This is equal to, we add these terms as well. 3 plus 9, that gives us 12. 5 plus 7, that's 12. 7 plus 5, that's 12. 9 plus 3, that's 12. Can you see what this uncovers is the fact that the 12 just keeps repeating itself. Now this is to save a student who wants to think critically of a situation, because when we take a finite arithmetic series that is just sizable for us to learn something about it, it becomes a lot easier. So we continue and say, well, this is the same as 2 times AS equal to, but we can see we are adding 12s as many times as we need to. So this is 12 plus 12 plus 12 plus 12. So basically this is 4 times 12. Okay, very nice. This is 4 times 12. And now we can divide by 2, because we still want the sum. We're not interested in the trick. This is just a technique to get things moving. The 2's do that, and then that's what remains. And what do we end up with? We end up with our arithmetic series equaling 2 by 12, that's 24. See how nice it is. This one is much easier to handle, rather logically, than to have to add all these terms up one after the other. Let's say we didn't have a calculator. This would be a bit tricky, right? Although this is very easy, because the situation is that it's sizable. We can actually see where we are going. But a smart student was asked a question for a very long series. Of course, a smart student will just cut that into a short thing. Observe what is going on. And if we do it like this, we see that we keep repeating the first sum all the way, as many times as the original terms were. So this was term 1, 2, 3, 4. So can you see we said 4 multiplied by the sum of the first term. Remember, this is the first term. That was T1. This is the last term. That was Tn, for example. Or we can say TL, as in the last term, whatever. As you can see here, we just added the first to the last, and we know that this is going to keep repeating if we set it up in that manner. It keeps repeating that sum as many times as the original terms were. So we had 4 terms, meaning the last term was term 4. We just said 4 multiplied by the sum of that. And that's how we get this. And then, of course, whatever we get, we divide by 2. Then it gives us the sum of those individual terms. So this is a very nice technique to think about, especially when given a very long series. But in this case, it means we need to know how many terms are there in this sequence for us to use this technique for a very long sequence. Let's say, for example, maybe let's say this was A. And then let's take B. Let's say we still had a similar thing. 3, 5, 7, 9. And then this went on to what are we going to take it to? I am trying to think now. What are we going to take this one to? Let us see. I just wanted to increase it a bit. Now my brain is locked. I don't know why I'm distracted. So let's just take a term in the sequence. Let's say 1, 1, 5, for example. Okay. So now we wouldn't know how many terms there are in here. It would become a bit of a situation, but we can see that from this trick, we could have learned how to handle this. Let's say we know that this is term number 57. Okay. And then, of course, this is term 1, term 2, term 3, term 4. And then the terms keep on doing that until we get to term 57. So what is important is for us to know that the last term is 57. But if we don't know, there's a way of finding out. Let's say we didn't know. Remember, we use what we know. So we know that Tn is going to be A plus n minus 1 times D, right? Right. Now we know the term here is 1, 1, 5 equals A is 3 plus n minus 1, D is 2. Because we can see the difference is 2 there. So this is 115 equals 3 plus 2n minus 2. So this is 115 equals 2n plus 1. So we've got 2n equals 114. Therefore, n is going to be, now 114 divided by 2 on our calculator is indeed 57. Okay, good. So if one didn't know, since this is the last term, this is how we get the number of terms. So remember, we may not be told at times, meaning one would have to perform this operation by themselves without being directed. But at times, we can be told that this is the 57th term, and we need to find the sum. Now, we understood from above that we literally take these dudes and add them up together as many times as we have. So, and we divide by 2. So we can easily say, well, we would know that the arithmetic series here would be equal to how many times? 57. So this is going to be 57 multiplied by, we just say 3 plus 115, and we divide this by 2. This is understanding that technique. Can you see this is much easier now once we know what to do? So this is going to be essentially what we need to do. Now let's see, this is 57 times, this is going to be 118 divided by 2. Okay? And of course we know 2 goes once. How many times does it go to 118? Let's think. 118, that should be 57, isn't it? Exactly. It should be 57. Am I seriously telling the truth, Mfethu? Not 57, 59, I think. Let's say 59 by 2. Yes, it's 59. Okay, that's the one. So all we have now is 57 times 59. Let's imagine we didn't have a calculator. So a student who knows long multiplication can do this in their head. You may sound smart doing this, but you're not actually smart. You're just using what we know. So let's put the bigger number on top, the smaller number there. Doesn't really matter though how we do it. So if we're multiplying this, we're going to say 7 by 9. Now guys, you need to know the times table, unfortunately. If you don't, then you are in the big problems, right? Yeah. So you should know that this is 63. And then we carry the 6. Then we say 7 by 5. That's 49, right? Ne? Yeah, man. Did I say 45? It's 9 times 5, that one. 7 by 5, it's 35, sorry. Oh yeah. This 3 is here. That was 63, Ganen. And then we said 7 by 5, that's 35, right? And then we add that 6 we carried. It gives us 41. So we write it like this. And then since we are on the tens, now remember these were the units. Now once we are on the tens, we need to accommodate that. So we write a 0 here. Then we say that one is going to be 45. We put 5 there. And then we carry the 4. Then we say 5 by 5, that's 25, plus 4, that's 29. Right. Now, we just simply add. So I didn't write this one properly. So this one is going to be 29, like this. And all we do now, we just simply add these things. Remember, with long division, we divide and then subtract. With long multiplication, we multiply and add. So can you see these things? They work nicely. They work nicely. Okay, let's see. This is going to be 3. This is 6. This is 13. This is 13. Hey, makancane wena. So sinikeza inamba enkulu kangaka. 13. Then we carry the 1 there, it becomes 3. Ay, athi siyibona. Thengathi ufuna ndihlanyisa nje. Ngisazikhumbula phela lezi zinto. But ingathi ngichanile ngibhekile nje. Yes, ngichanile. So guys, you need to know how to do long multiplication, so to speak. Of course, at times you go wrong. But remember, yes, you may take a while to do this. Whether you're doing it on a small sheet of paper on the side while the teacher is asking this question, or you just simply look at it and deal with it in your head. This can be performed in the head. You see? It can be performed in the head. So this is what we get, guys. 3, 3, 6, 3. This is what we get for this situation. Can you see a very complicated situation can actually be simplified using, a particular trick. So that was the trick applied by one student when asked by their professor what is going on. I forgot actually who was the professor and who was the student, but this is the basis to dealing with these kinds of things. They came from long ago. You can check this on Google or whatever, but you will find out. I forgot who said this, but it is indeed something that was phenomenal. So remember, when you take smaller things, you play with them a bit, you'll start to notice a pattern like this one right here. Once you notice a pattern, what happens? You can use that to your advantage. So we used this pattern. And actually, once we do this, we see that we repeat the same thing as this plus that. Doesn't matter what we have in between. It gives us exactly that, and so it repeats itself. And so we can use that and deal with this situation. But then, guys, you start to ask yourself, but what happens when you make a mistake and all this? Because remember, when you don't have a very clear but a clear solid structure, then you tend to have issues. I mean, this is bulletproof, by the way. We can see it works. And this time we did not even need to align these sequences, these terms in reverse. We already know what it's going to take us to, so we just used that as our way forward. And again, in maths, guys, we need to learn to do that, all right? Even to find the number of terms, it's as simple as just taking this first term, and essentially taking the very last term, together. And what did we do there? We just simply subtract. So we take the last term, we subtract the first term, and what else do we do next? Then we divide by the common difference. Of course, we can play around it and say we need to first split here and say, okay, all right, okay. In this case, now this is another technique, guys, that you need to know. Let me just show you this thing, what I'm trying to say, because I'm starting to feel like I'm lying. So this is Tn equals A plus n minus 1 times d. Now we just want to know the number of terms here. So remember, we'll transpose this, right? And then, of course, this gets distributed first. Now I'm just going to move quick because there's no time to play here. So all we're going to say, we will simply say n is nothing but the last term minus the first term. But remember, this is going to be minus d. When you transpose it again, it becomes plus d. All of that is going to be divided by d, because this would have been dn. Can you see? If you know this, you don't even need to start all of this that way and suffer. Just know that if my common difference is positive, I'm going to be adding it here. Just take the first term and subtract the second, and I'm adding the common difference and also dividing by it. The common difference is negative, then it's going to be negative there, and it's going to be dividing by it here. If the first term was was negative, you're going to be adding it here instead. So these are some of the things that as a student you need to be comfortable doing. You don't need your teacher to tell you these things. You use your creative mind to get around issues, and don't be afraid of seeing things for the first time, and just play with them before you start to follow the structure, because you will see the disadvantages of how you play with these kind of things. Then that opens your mind. You start to see exactly how to get around issues, and at times when your logic is needed, you will really easily apply it because you've been doing this the whole time. So this is a nice way, honestly, to introduce topics, I suppose, because you need to pick the brain of your students as a teacher or a tutor, and your students need to really exercise their mental gymnastics, and eventually we show them the way, and hey, then it starts to become all nice and sweet. Now, guys, we want to say, okay, how do we do a series? Now, not really doing these tricks and techniques that we've seen. How do we handle this nicely? Okay, let's derive the formula now. So we want to derive the formula. the derivation. Okay, maybe let me write better. Derivation of, okay, my of is also not right, of of the arithmetic series. I write badly, that's just the thing. Sn, not Sn like that, but S sub n. Okay, good. So how do we deal with this issue? Now we go back and say, in principle, an arithmetic series can be the first term plus the second term is going to be the first term plus the common difference, right? Right. Plus the first term plus twice the common difference, okay? Because this is going to be d plus d twice here. That's why we say twice this. And then, of course, guys, this is going to go on until Jesus comes back. But we know the last term is, it doesn't really matter. Okay, let me think now. The last term is going to be what? It's going to be a plus, now I'm trying to think. Okay, since we put the first three terms, we need to be consistent. We need to put the last three terms so that we don't mess it up. Now this is going to be a plus, this is going to be n minus 2, n minus 3, sorry, times d, isn't it? Because we could see that this is how it's going, and this is how it's going to reduce until we get to the last one. This is going to be a plus n minus 2 times d, and then the last one is going to be a plus n minus 1 times d, the last term. The reason why we know this is going to be the case is because the last term has to be like this. And where did we get this? We proved it in the previous lesson that any term in the sequence which we could consider as the last term is like this. We proved this formula. Now, knowing how sequences work in an arithmetic pattern, we knew that when we hit the last one, we start reducing by just one from each number until we get to the last. So again, this is a technique that needs to be clear in our heads. You may be wondering, how did I know this is going to be the case? It's just logic, pure logic. Of course, we played around this, and now this should be an easy thing to deal with. Okay, so we're going to do the same thing, guys, and say the arithmetic series is in this manner. Now we start writing it in reverse. So we're going to have a plus n minus 1 times d plus, then we're going to have a plus n minus 2 times d, then we're going to have a plus n minus 3 times d, plus dash dash dash, and then of course here we're going to write all of these things in reverse. Wait a minute. Yeah, this one is going to be aligned with this one. It's going to be a plus n. This is going to be a plus 2d plus this one is going to be a plus d. The last one is going to be a over there. Okay, so obviously we decide we're going to add these terms like that. So meaning this one adds to that, that one adds to that, that one adds to that, and. Okay, so that's how we're going to do this. So of course we write Sn here. Let me not write As. This is S sub n, meaning it's the series. So we get 2 times Sn equals, now this will force us to break this open, isn't it? This forces us to break this open, but let me think for a second. This is nothing but a plus a. There is going to be 2a plus n minus 1 times d. Okay, let's keep this one like that. This is what we get. It's a complex term. Plus, we deal with this. Again, we get 2a. But now we need to break this up. So we have a plus d, right? Plus a, and then here we break this up. It becomes nd minus 2d. Now a plus a is going to be 2a. And then d minus 2d is going to be plus nd minus d. Okay, now we can take d out. It's going to be n minus 1 times d. Can you see? This very term repeats. It's going to be 2a plus n minus 1 times d. This is what we get. Although we needed to perform some side calculation, that's what we get. Okay? Plus, so let's play with that one. So we've got a plus 2d plus a plus n minus 3 times d. So we've got a, the a's deal with each other. We get 2a plus 2d plus 3n minus 3d. So those take each other out. We get 2a plus 3n, not 3n. What was this? That was supposed to be 3d, sorry. Now this is 3d. I don't know what I'm doing now. I'm messing up. I am messing up. So this would have been dn, okay? And so this is dn minus d. Can you see? So if we sort it out, that would be 2a into n minus 1. We take d out. Can you see? The same thing repeats, no matter what we have. So we get 2a plus n minus 1 times d. That's what we get. Of course, knowing the pattern keeps repeating, at times you may not need to repeat this as many times as we have here. But hey, what does it matter? We can continue and do this. It's going to be 2a plus n minus 1 times d. Plus we do this. It's going to be 2a plus n minus 1 times d, plus the last one is the same thing. It's going to be 2a plus n minus 1 d. Okay, I was running out of space there. Not a big deal. And then we know that, well, 2s sub n equals as many times as these are. And we knew that this is t1. This one was tn. Okay? So this was t2, t3, and of course it went all the way until. So there are n terms here. So that means these things are exactly the number that would represent. So this is going to be n into 2a plus n minus 1 times d. And so when we divide by 2, the 2 does its own thing. So we see that essentially s sub n is going to be n over 2. We can just factor this out into 2a plus n minus 1 times d. Okay? So this, guys, is the formula to calculate the sum in an arithmetic series. And this is, by the way, examinable. This is examinable. So you will come across this question and it's easy marks. Can you see the technique looked crazy at first? But it works, and guess what? That's how we derive the equation for the sum of any number of terms in an arithmetic sequence or series. Now this can be looked at in this way, that S sub n is n over 2 into, we can split A into A plus n minus 1 times D. Now this would imply that n over 2 is equal to, this is A, the first term, plus, can you see, this would be any term in the sequence or series. We can regard that as the last term. And that's it. So this is another variation. So literally, if we know what the last term is and the first term is, we just add those up without going through this whole shenanigan that we did. Okay? So this is when this is regarded as the last term, literally. As we said, that this could be looked at as the last term or any term. Nice. Okay. All right. Okay. So these are the main formulae to deal with. And the nice thing is, this is how we do the derivation. This is the derivation. So we're deriving it. We're not differentiating. Differentiate these two. This is derivation, or we derived. But in calculus, when we take the derivative, we're actually differentiating. Similar, it's a similar thing actually, and a similar thought, but I guess the issue is with the actions, you know. If you look at differentiation, we're actually distorting the function, isn't it? If the function was cubic, we're distorting it to a quadratic function. So that's like taking something into something else. Whereas here, we're just taking exactly what we have, but we're making it summarized. We're summarizing it. But it's nothing but the same thing, because we could easily get everything back if we wanted. If we wanted the first term, we can get it from here. We can get it from here, because we know that the sum of the first term is exactly the first term, because what else have you added? Nothing. So it will give us A. It will give us A, because look, if we say n is 1, this is going to be a half, right? N is 1. 1 minus 1 is 0. 0 multiplied by anything, it's gone, right? So we end up with 2A over 2. 2 divided by 2 is 1. So A. Done. So we end up where we started if we play our cards right. Okay. So that's the story. That's the story. So anyway, guys, just know this thing is examinable. That's why I wanted to introduce it in a nice way, so that you can appreciate the things that need to be done. Now let's take some worked examples. Okay, guys, so I have written this quickly. So the question says, evaluate the sum of the series below. This is starting from 5, 13, 21, up to 28 terms. Can you see we're told the number of terms, which is what we highlighted at the beginning, that if we don't know the last term, at least we should be told how many terms are in this series. And of course, if we look at our series, we will see that the common difference here is what? It's 8, isn't it? Yes. We see that the common difference is 8 here as well. Okay, so this is D. All right, so let's have a look. We know that Sn is going to be n over 2 into 2a plus n minus 1 times d. This is the best formula because we don't know the last term. But if we like, we can find that last term. So this is going to be 28 over 2 into 2 into the first term, that's 5, plus sorry, this is going to be 28 minus 1 times 8. Okay, so here we can get the answer and say S28 is, at this point guys, you can just go about it nicely. In the calculator, this can be done easily. Just make sure your substitutions are correct. And if that is the case, you are home free. Believe me. So I'm getting 3164. That's easy. Now the key here, guys, there's no proving that you are correct here. It can be very technical. So the best thing to do here is to ensure that this step here is good, because this is usually a 2-mark question. Correct substitutions, answer. Another student may choose to first find Tn, because remember, we know that this is 28 terms, so we want to know what is term number 28. This is 5 plus 28 minus 1 times d, which is 8. So let's see. Again, what matters the most here is this step. Otherwise, everything else should be easy. 5 plus basically 27 times 8. It's 221. Okay? We can say therefore Sn is equal to n over 2 into a plus l. Okay, this means S28 is going to be 28 over 2 into 5 plus 221. And let's see what we get over there. So we have essentially 28 by 2 into 5 plus 221. We still get the same answer, 3164. So this is another way of handling the same problem, but you can see this one involves 2 steps. Do you really need that? I don't think so. But again, if that's how you feel, this is going to be easy. You can go about it that way. But if you see that this is complicated, once you don't know the last term, but you know the number of terms, this formula is the best, which is exactly what we derived. That's the main formula. All right, guys. So this is very, very interesting. Let's take another worked example just to get into the groove. Okay, guys. So we've got our series there. And of course, we know this is arithmetic. When we don't know, we need to check. But let's check as if we don't know. We can clearly see here that the common difference here is 0.5, isn't it? Exactly. That's what this is. So we know that our D is one of those. So we know the last term, we know the first term. So the best formula here is to use Sn equals n over 2 into A plus L. So n is, okay, now we have a problem. We need to know the number of terms. Unfortunately. We definitely do. So we saw what we can do here. We know that n is going to be the last term, which is 40,5 minus the first term, which is 0.5. Then we add the common difference because it's positive, and then we divide by the same common difference. Let us see, what do we get? 40,5 minus 0,5, sorry. I mean, that's gonna be, in fact, why am I suffering? Why am I suffering? Because these two take care of each other already. So all I have is 40,5 divided by 0,5. So this gives us 81 terms. Unfortunately, we need to know the number of terms. So from here, what do we do? In fact, we don't underline an intermediate answer. We can say then Sn is equal to n over 2 into 2a plus, okay, we want to use a when scanteen nagamon scanteen. It's gonna be a plus l. This implies that S81 is gonna be 81 divided by 2 into a is 0,5 plus 40,5. Therefore, S sub 81 is going to be 81 divided by 2 to 0,5 plus 40,5. Okay, so the sum here is 166.0,5. Nice and easy. Okay. Again, one can use the other formula here, but this step was necessary. When we don't know the number of terms, we have to find the number of terms. We don't have a choice. Again, I only used here Tn equals a plus n minus 1 times d. That's what I used. You can go about it this way because someone may ask, what the hell? But in any case, the mark is here. You don't really get a mark for this because that's not what we were asking. What we were asking is here. You'll find that this is a 3-mark question because the substitutions are marked here and the final answer. And the third mark is to discover how many terms there are. So knowing how to do this is good because how to look for it is not interesting at all. What is interesting is getting the right number of terms. But remember, you can use this formula. But what I did, I just pulled this apart to say n is going to be Tn minus a plus d all divided by d. That's essentially what I did, just to avoid unnecessary strain. But hey, this can be dangerous if you don't know what you're doing. Okay, but you will see the utility of this technique as we do more and more examples. All right, folks, so this is very interesting, and this is in fact as good as it goes. All right, so let's find another worked example. Okay, guys, so there is our worked example 3. So you can see the differences in how these questions can be asked. So again, we are supposed to determine, this time we need to find the number of terms. Okay, but we are told that the sum is equal to 295. So again, we just need to find out what is the common difference, because if we don't know this, we are in trouble. So we know that 16 to 19 is just 3, and 19 to 22 is just 3. So the common difference is 3. So you can make a declaration that D is equal to 3. I knew there was gonna be trouble. I didn't have to hit this thing, my lord. Okay, so D is effectively 3. Nice. So what do we know? Sn equals n over 2 into 2a plus n minus 1 times d. Now Sn is given as 295 equals n over 2 into 2 into first term is 16 plus n minus 1 times d, which is 3. Okay. So what do we do here? This is over 1. So we cross multiply here straight away. So 295 times 2 gives us 590. Is equal to, now this is nothing but n into, we can sort this up, this is going to be 32 plus 3n minus 3. Okay, so we go on and handle this situation. We have 590 equals n into 3n plus 32 minus 3 is 29, isn't it? Yeah, boy. Okay, so we see that we end up with a quadratic, right? So this is 590. Be step by step, of course. 3n squared plus 29n. So we go on and write this in standard form. This is 3n squared plus 29n minus 590 equal to 0. So we say 590 equals 590. Then we go shift, fact. What do we get? So we get here 2 times 5 times 59. Okay, so that's not a big deal. We know that we want 29. So we can actually multiply this 2 into 10 times 59, right? Right, it will work. So we're going to say this is, we factorize. So we're going to have 3n and then n. Now we want the bigger product here to have a positive number. So this one must be here. We can say plus 59, right? Then we put 10 in here, because this is minus 30 plus 59. So 59 minus 30 gives us 29. So it's sorted. So we know that therefore n is equal to 10. Remember, n is an element of natural numbers. Do not forget. So the negative one does not matter. We are not interested in it. In fact, it's going to give us a decimal anyway. All right, guys. So this is how a question like that is handled. And usually it hurts a bit because you end up with a quadratic. As you could see, algebraic techniques don't disappear. Somewhere along the way, they will find us. So we need to be in a position to sort this out. Now, how many marks would one get for a question like this? Obviously, the correct substitutions into the formula is what matters. To factorize whatever we get is what matters. And getting the mark is what matters. And of course, uncovering the common difference. Usually, this would be 4 marks, 3 marks, but certainly no less than 3 marks. Okay. All right. Okay. And of course, some students, when it comes to this step, they may actually opt for the quadratic formula. That's okay. It's not a big deal. Now this one we can actually check the answer, because if we say n is 10, so we put it back and see if the left hand side is going to balance the right hand side. So let's say 10 divided by 2 into 2 into 16 plus 10 minus 1 times 3. Let's see. We definitely do get 295. So 295 is equal to 295. And so we know that n should be 10. Okay, good. Of course, knowing that this must be a natural number, meaning positive integers. So we can't take the negative integers. So guys, this is very nice, very easy, no issues here. So we need to just keep it moving. We need to keep it moving, okay? But now I'm trying to think of something though. I am trying to think of something. I mean, I want to put as many examples as I want, but the problem is I cannot do that, okay? How many examples? We did 3, so let's do a bit more. Let's look at some worked example 4. Okay guys, so here is another worked example. So here we are told that the sum of the first n terms of a certain sequence is given by this formula, Sn. Okay, so now the question is, we need to find the first term, sorry, the sum of the first we need to find S1, okay. We need to find S2 and S3. Okay, let's have a look at that. So we can just say solutions. So we have A. Now we know that S1 is going to be 1 all squared. Okay, here we can write Sn is equal to n squared plus 2n. So where we see n, we put 1. So this is 1 plus 3, sorry, 1 plus 2, that's 3. Okay, and then we know that S2 is going to be 2 squared plus 2 into 2. Now this is 4 plus 4, that's 8. And then we say S3 is equal to, now let's see, this is going to be 3 squared plus 2 into 3. Now this is 9 plus 6, which is 13, ne? Oh, that's 15. Is it 15? Diabua, 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 diabua. Yeah, man. Yeah, this is 9 plus 6 is gonna be 15. Yeah. Yeah. Kimatada. Abu Pilo. It's very sharp. Okay. It's not bad. So obviously guys, here it's just substitution and answer. So we would probably get 3 marks for those different answers, isn't it? Yeah, man, let's look at B. Maybe let's cut this into 2. There's so much space here. So slanted. Damn it. Damn it, man. Okay. So let's look at B. B, what are we supposed to do? We need to find T1, T2, and T3. Now notice, guys, the sum of the first term is nothing but the first term. So we know that T1 is actually going to be S1. Therefore, T1 is basically 3. So always remember that if we're given the general formula for the sum, we know that S1 is nothing but T1. But now we need to deal with T2. T2 is going to be basically S2 minus S1, isn't it? Think about it. If you take the sum of the first two terms and you subtract the first term, what do you get? You get T2. Exactly. So this is going to be essentially S2, that was 8, minus 3. So this is 5, okay? Then we see T3 again is going to be the sum of the first three terms minus the sum of the first two terms. Remember the sum of the first three, and then we take away the sum of the first two. We will only remain with T3. So this is another technique, guys, that's very important to notice. It hasn't been asked recently for a while, but we need to appreciate it. We need to appreciate it. So 15 minus 8. Irifamang. 7, right? Right. So we can say, therefore, the arithmetic series, was it a series? Or we're told this is a sequence. So we can say, let's say of a certain series. Maybe let's make it, because we're dealing with series here. Let's just say series. Yebo. So it's going to be 3 plus 5 plus 7, and it goes on and on to n terms. All right. Or maybe we just write it like so. Let's write it like so until Tn, whatever the value that is. Okay, guys, we did it. So this is very important. Please cement this into the head, that if we want the third term, when given the sum, it's going to be S3 minus S2. It gives us the third term. And as you can see, this is arithmetic because the common difference is 2 here. All right. Okay. All right. And how would we know that it is 2? From what we did before, we could see that when something is quadratic, we divide by 2, right? Common difference was 2 here. So we say 2 divided by 2 is 1. Okay, that sounds crazy. But in any case, this is not the quadratic things, but it's quadratic itself. Can you see the sum of an arithmetic sequence is actually given by a quadratic pattern, so to speak, or should we say a quadratic formula? Okay, maybe forget what I just said, but just remember that the sum for an arithmetic is going to be described by a quadratic formula, sort of, or general formula. So this is a very important thing to remember, guys. So please don't forget this technique, because a lot of students crumble when it comes to this one. So let's answer C. C asked a question, is the sequence arithmetic or not? The answer is yes. Yes, it is an arithmetic sequence or series. Let's say series, since D is equal to 2. Or it has a common difference. So that is the story. The explanation is that there is a common difference of 2. Okay, maybe let's answer properly. Let's not answer carelessly. Did we say sequence here? Yeah, let's say the series. Is the series arithmetic or not? We say yes, it is. We can say the reason here, because there is a common difference D of 2 between any two consecutive between any two. Now they're writing between any two consecutive terms of the series. Okay, always try to answer nicely. Make sure your answers tell us that you did look into things and you understand. All right, you can easily show us that that is indeed the case. All right, nice and easy. Okay guys, so this is essentially how nice this thing can be. So we can either be given a general formula or we can be asked to show us the general formula. Remember, again guys, you know what, to avoid an issue of giving you too much, this is sometimes better left at this stage. So we've introduced our topic nicely, showed you the tricks that you can use to get around things, and then we showed you exactly the right way to go around things, the type of basic questions that you should be practicing now. Remember, your next task is to take your textbook, sit down with it, and learn, okay? Practice as many questions as you can, because this is what matters the most, okay? Now let's take another question, maybe two more questions. These ones are going to be a bit challenging for a student, so don't cry, but get around these kinds of questions, all right? So we're going to deal with a question, or we're going to deal with okay, maybe let's take a basic question before we get to those hard ones. Maybe a basic one. Okay guys, so here's a nice worked example for you guys to have a look at. Question says, find the general formula for the sum of the first n terms of the series 5 plus 8 plus 11 and so forth. All right, again, we can easily appreciate that this is an arithmetic series. Difference here is 3. So the common difference is 3, okay? So what do we know? Sn is equal to n over 2 into 2a plus n minus 1 times d. Remember the instructions, guys, always tell us that we need to show exactly the method we used. So if we don't write the formula, we don't know which formula you're talking about. So you may lose a mark for the substitutions, even if it's correct. We need to know on what structure are the substitutions based on. So this is n over 2 to 2 into 5 plus n minus 1 times 3. Okay. So S sub n is n over 2. We can break this up. This is going to be 10 plus 3n minus 3. S sub n is n over 2 into, this is 3n minus 7. Okay, so we can write the formula and say Sn is going to be, we multiply there, this is 3 over 2 n squared minus 7 over 2 n. All right, so that is essentially the formula there. And we can appreciate that this formula is quadratic because the highest power is in the order of 2. Therefore, it makes it quadratic. So we can see that the general formula for the sum of terms in an arithmetic sequence or series is described by a general formula that is quadratic. Great. Not a big deal. Again, guys, here what matters is substitutions and the answer. This would be 2 marks. provided you do show that this is how you started the business. And of course, identifying the common difference. Maybe it's fair to write it down, because that would be another mark on its own. Okay, so perhaps 3 marks for a question like this. So this is very easy, folks. Nothing really difficult here. Now let's take some challenging questions and run with them. Okay, so let's take another worked example. So this one is going to be a bit complicated, but again, you will just appreciate how so much you know and how much you can do with this. Because remember, if we just leave you with the basics only, you will think that's all you need. No, the basics are there to build your knowledge so that you can use it even in situations you may have not been introduced to yet. But when you see them, you get them done. Now let's look at worked example 6. Let's underline it. Now the question says, Mrs. Jones buys a washing machine at a price of 1,600 rands. So this is the amount of money. Now, if she can manage to settle the whole account during 1 year, no interest will be added. Can you see? No interest will be added to the original cost price. Very important. Now, during each of the first 3 months, she puts down an amount of 80 rands. Okay. Now, to avoid interest, she decides from the 4th month onwards to pay 20 rands per month more than each previous month. Okay. Now the question asks, how long will it take her to pay for the washing machine? Great. Now remember, guys, first 3 months she pays 80 rands. Now let's just look at the scenario nicely first of all. So okay, solutions. For starters, we have 80 rands, 80 rands, 80 rands. These were the first 3 months, right? And then after that, from the 4th month, she added. So this is going to be $100 going to 120, going to 140, going to whatever. So this is what is going to happen. And we can clearly see here that the difference between these 2 months is just 20 rands each. Remember, this is mula. Kimashankura. So you can see that the common difference here is nothing but 20 rands. So this is very important. So we can see that if we decide to cut this series or sequence, whatever, we can cut this sequence into an arithmetic sequence. Let's just say it's an arithmetic progression. This becomes an AP. But remember, this becomes just something on the side. So this is the money that she has paid already. And if she's paid this is nothing but 160. So this is $160. Remember, what was the total? This had to add up to $1,600. So this already means if we are considering this series has to add up to what? 1,600 minus the first 160 rands. So this gives us essentially one. If you calculator, I'm doing a guys. Yeah. So 16 minus 160. So I get 1.440. Okay. So we can see that essentially the total of this series, because this is more like a series, we're going to have to add all this amount of money. So we may not look at it as a sequence per se, but as a series. Yeah, man. So this has to add up to, it has to add up to 400. So 1,440 bucks. Because we have paid the first 160 rands in the first 2 months. Because if we were to look at terms, this would have been T1, T2, T3. But since these are a little bit strange-ish, this didn't make sense if we started from the first 2 months, because we literally repeated. But this follows a nice arithmetic progression, or arithmetic series for that matter. So we can see that we just need to know how many terms this is. It's going to be the number of terms in the arithmetic series, adding up to 1,440, plus the first 2 months. Right? Right. So this is it, guys. So can you see, if you plan this nicely, you know that this would be term 1, term 2, term 3, up until Tn, which we don't really care at the moment. We would find out. But from term 3 onwards, we saw that we actually formulated an arithmetic progression, or an arithmetic series. And so we can use this to find the number of months this would be, and to it we are going to add those first 2 terms. Okay, this is indeed great. So can you see, guys, if you understand what you are given, you can put it down into some kind of a sequence that you can follow. At times it's not going to be exactly the first 2 months. As you can see here, you need a bit of strategy here. You could easily take these alone as the first 3 and start from 100 going forward. It doesn't matter. And you can say this is arithmetic, and maybe that one is whatever it is. It doesn't really matter. So it depends on how you want to cut it, but as long as you get it done, that's what matters. So we know, guys, that Sn is going to be n over 2 into 2a plus n minus 1 times d, right? This implies, now we can clearly see that if we wanted to show this mathematically, it's going to be 1,600 minus the first 160. In fact, we can say 2 times 80 to show that we're just looking at the first 2 months, equals, now this is n, which is what we want, over 2 into, now the a here is going to be 80, plus n minus 1, which is what we want. Common difference here is 20. Can you see? Applying sequences and series to sort out issues. So we saw that this gives us 1,440 equals n over 2 into 160 plus 20n minus 20. Right, so let's sort this out nicely. In fact, I didn't need the big ones because I've already broken down the small ones. So this implies, in fact, I can cross multiply here already before I proceed any further. So I'm going to have that by 2. This is going to give me 2880 equals n into 20n plus 140. Okay, so this implies, now guys, we can see this is going to be a quadratic, which is going to be 20n squared plus 140n minus 2880 is equal to 0. So we write that in the proper order. Of course, all of this can divide 20. So it's always nicer to try and reduce things. So we get n squared plus, say 140 divided by 20. It's 7. minus, we do that one, 2880 divided by 20, it's 144 equal to 0. See, we have a nice quadratic. And we know that 144 is a perfect square, so we're not gonna get there. So we need to do our gymnastics. So I say shift fact. So this gives me 2 to the exponent 4 by 3 to the exponent 2. Now we need to play with this. This is 9 and 16. And definitely 9 and 16, the difference is 7, right? 16 minus 9 is 7, yes. So this is good. We don't need to modify these. We leave them as they are. So this implies that we have, again guys, you can use the quadratic formula, but factorization is much sweeter in my opinion. The big one must be 16. The small one must be 9. Okay, so we know that therefore n should be equal to 9 since n is an element of natural numbers. We can say therefore, remember this is not the answer, this is just a means to an end. We can say therefore, what was the question? How long will it take? Therefore she will take 9 plus 2. Remember the first 2 months. 9 plus 2, which is equal to 11 months, to pay off the money. Is it the money? To pay off the machine, the washing machine. Okay, so always answer the question fully. Can you see? These are some of the questions that will definitely horrify a student who's not paying attention. So it helps a lot to know. Can you see? There's a whole lot of things included here. First of all, we needed to interpret what we were given in a way that would make sense according to the topic we just studied. But remember, this could be a random question in the exam. And this can give you some heavy load on your chest. Or it could be a question in the NBT, you know. So you need to know how to do this nicely. And if you don't know, then you are dead, okay? Ushwile ngwanabatu. So this is the story. This is the story, guys. So let's have a look and see what is the story now that needs to go on in here. Now the last question says, what installment will she pay during the last month? Okay, and we know this is going to be 9 months, right here, and then we still have those 2 months. Okay, all right, okay. So we need to be very strategic in this thing, that the arithmetic sequence here, we will just disregard this for a while. Say our arithmetic sequence went for 9 months, okay, because we can't say this is term number 11. The only thing that made sense was the arithmetic sequence or arithmetic series. So this is the only thing that made sense. So in the arithmetic series, the last term is term number 9. Now we need to find its value, okay? Because that is exactly what we need. Because this is what the question is asking. What would be term number 9 in the arithmetic series? Can you see, guys, how interesting such questions are? So to answer B, we know that this is very easy, guys. This is arithmetic. Tn is A plus N minus 1 times D. Very simple calculation. So we say T9, because that would be the 9th payment in the series, essentially. The first term was $80 plus N minus 1. Sorry, this is 9. So this is going to be 9 minus 1 times D. We saw that D was 20. Therefore, T9 is, now at this point, it doesn't really help to simplify anything. We just go with the flow. So this gives us 240. Now we have to answer the question, right? We can say here, therefore, she will pay pay 240 rands during the last month. Okay, easy. So solve something somewhere and then learn to answer the question eventually. So this was a very nice question, guys. As you can see, it picks your brain a bit, but it's nothing out of the ordinary. So we're combining our series and our sequences as we have studied nicely above. So it helps to be very smart and to know what's going on, because if you don't know what's going on, you will not understand even when you see that. Like, but why? It makes sense now that we all understand. Okay, maybe let's pick another tough question and stop before we take this one too far. Okay, guys, so here's another technical question that sometimes may give a bit of a headache. You know, these are one of those questions that you are asked last in any section in maths. Sometimes you can be asked the easy questions and then you end up with these kinds of questions. Now, question is, we need to find the sum of all multiples. Can you see? All multiples of 3. So this means these are essentially numbers that can divide 3 between 1 and 400. Okay? So this is easy, but only if we know what we are doing. What are the multiples of 3 between 1 and 400? We know that essentially the sum, we know that Sn is going to be equal to, so it's basically 3, right? 3 is the first one, isn't it? Because 3 can divide 3. So 3 is a multiple of 3 because it's 3 times 1. So be very careful. And then the next one is 6. The next one is 9. The next one, we don't care. Now, the trick with this one is to find the last one. Now, let's check. 4,000 cannot divide 3, right? I mean, 400 doesn't divide 3 into a whole number, so it's not a multiple of 3. Let's say now 399 divided by 3, it gives us 133. So this means the last one is going to be 399. So we always try to see what is going on in here. And as we do our things, we win. So the technique here, guys, is to find the last term and the first 3 terms, because they will follow a particular pattern. So we need to find the first 3 terms and the last term, because then we would know how to go about our business. We can clearly appreciate that this is arithmetic. Or maybe let's do solution. So we see that the difference here is 3. Common difference is 3. So we can write here and say, therefore, D is equal to 3. So now we have an issue. We don't know how many terms there are in here. We know that n is going to be the last term minus the first term plus the common difference divided by the very common difference. Again, you can go about it the standard way. Tn equals a plus n minus 1 times d. It really doesn't matter how you get to the answer. For me, I just want to get to the answer easily without explaining too much. So I basically have 399 divided by 3 gives me 133. So n is 133. Now, what do I want? The sum of 133 times, but I need to write the formula first, because now this is me answering the question. It's going to be a plus l, because I know the last term, I don't need to suffer. This implies that S133 is going to be 133 divided by 2 into 3 plus the last term here is 399. Therefore, S133 is equal to, okay, let's see, 133 over 2 into 3 plus 399. Okay, get a very nice number there, 26 scored, 37 and 33. Cool. So can you see, guys? So that's the one. That's the one. So very easy. Very easy. But the trick was we needed to find the sequence. It was not nicely given. So the most important was to first find the sequence and then study it, the series. We needed to study it and discover that there's a common difference of 3. And so we knew that the next thing we need the number of terms. And we saw what the number of terms is. And now we knew the easy little job to do here was to go about it the standard way. All right, guys. So this is very important. Marks could be scored here and here. Correct substitutions and the answer. The sequence per se is what you need to find as a student. Nobody cares whether you find it or you don't. This is what matters. But again, to have a structure is important. So this could still be considered for a mark. It may not be considered for a mark. It doesn't really matter. All right. It really doesn't matter. Now, guys, let's take one last question here and cut this video before we take too long. But I still wanted to introduce the sigma notation in here. Maybe I may just do that, but I'm feeling like sigma notation though is best if I discuss it when we are dealing with maybe the last. Let's push the sigma notation to the last. Let's not rush it. Let's just take another example and see what we can do with it. Okay, guys, so here's another worked example. We are asked to determine the sum of the natural numbers up to 1000 which are not divisible by 5. Now, this becomes a bit of a situation, because how would you know what to do? Well, there are many ways of approaching this problem, but sometimes it may not be so easy because, for example, of the natural numbers, you will see that the distances between them, the ones that are not divisible by 5, they don't really form a particular sequence that we can follow, right? There's going to be some crazy jumps along the way. Let's say, for example, those that are not divisible by 5, it's 1, 2, 3, 4, and then we skip. It's going to be 6, 7, 8, 9, then we skip 10. Can you see? We can't really see this pattern nicely because yes, the difference is 1, it's 1, then the difference is 2, then it's 1 again, 1 again, 1 again, then it's 2. Of course, if you can master this technique, but it would take forever to deal with this problem. So it clearly says that we can't look at it this way. Okay? We can't look at it this way. All we can say is that the sum of the natural numbers sometimes the sum of all these natural numbers is going to be 1 plus 2 plus 3 all the way to 1000. So this is what we have. And of course, the difference here is 1. Difference here is 1. So we know that the common difference is 1. Right? Right. Now, of course, the number of terms are going to be 1000 because remember, this is the 1000th number. So basically the number is 1000. So we're not going to bother here. So we just know, guys, that Sn is equal to n to a plus l, n over 2. So this implies that S1000 is going to be 1000 divided by 2 into 1 plus 1000. So therefore S1000, remember this is the sum of all the natural numbers. Now let's see, what is this? 1000 divided by 2 multiplied by 1000 plus 1. So this gives us this is 500,500 rands, right? Right, if this was money. So guys, this is essentially the sum of all the natural numbers up to 1000. But remember, that's not the question. The question is those that are not divisible by 5. But when we started to look at them directly, we saw that we're running into a brick wall. But now we want to actually bore a hole through that big wall. Now let's say, here's another situation. The sum of all the terms. Now these are numbers that are divisible by 5. Because we can actually look at it. This is going to be equal to, it starts with 5, and then it goes to 10, 15, 20. Maybe the first 3 is fine. And then this goes on until the very last one. Now remember, 1000 actually does divide 5. So the last term is the last one. Because let's see, 1000 divided by 5 is 200. So this is great. So these are the numbers that actually can divide 5. Again, when we study them, what do we see? There's a common difference of 5. So what can we say here? We know that D is 5, okay? Now we want the number of terms. Now this one won't be so easy. So we know n is going to be the last one minus the first term plus the common difference divided by the very common difference. And we saw that this is 200. So there's going to be 200 terms basically there. Okay? Because these ones will just take care of each other. But be very careful. Don't just say this is this one divided by that. It can be a lot complicated than that. Someone may just do that, But don't take this lightly. Remember, if you don't know what to do, you follow Tn equals A plus n minus 1 times D. We didn't prove this formula just in J because essentially this whole thing is nothing but the same idea. But I'm just going about it quickly. Okay? Now that we know there's 200 terms, so we just want the sum of these terms. So we can just easily say Sn is going to be n over 2. But remember, once we have written the formula elsewhere, we sometimes don't need to write it again. You know, we can just go for it. Say, well, S200 is going to be 200 over 2 into the first term is 5, the last term is 1000. Therefore, S200 of the ones that are divisible by 5 is going to be 200 over 2 into 5 plus 1000. This gives us 100,500. Okay, not a big deal. But remember, that was not the question. The question was the number, we want the sum of all the natural numbers which are not divisible by 5. Remember, we can take the very total sum, which is the grand total if you think about it. This is what we would call the grand total. And we could call this one sum sub total. Now we want the actual total. So we can say therefore numbers, the sum of numbers Sn of all numbers not divisible. Okay, maybe let's not say sum of all natural. Sum of all natural numbers not divisible by 5 is equal to, we'll take the grand total, which is 500,500 minus the subtotal, which is going to be 100,500, and this will give us what we want. So it's 500,500 minus 100,500. So this gives us 400,000. That's the one. That's the one, guys. So can you see, it looks like a very simple question, but it's actually a bit more complicated because you need 2 steps before you get to the very easy last step, because we know that if we took out those that are divisible by 5, the remainder is the ones that are not divisible by 5. If we take it from the total of all natural numbers up to 8,000. Can you see? So the trick here was to first deal with the first sequence. We needed to get to the grand total. And then we then had to find the sequence of those that are divisible by 5. Sometimes this is the technique. Now we needed to know how many are these terms first, and then leading up to that subtotal. Okay, good. And so we then answered the question at the end. So these are some of those heavy questions that can be quite a nightmare for a student who doesn't know what they're doing. Of course, guys, I should have left you to figure out these kinds of questions on your own. You can find these kinds of questions in any study guide, mathematics textbook. Now your task is to sit down with your textbook, your study guides, past exam question papers. Try to tackle as many questions related to the arithmetic sequence, quadratic sequence, and an arithmetic series as I have shown you so far. Just to avoid making this video too long, I'm going to cut it here, guys. I actually wanted to introduce the sigma notation, but I do feel we need to deal with that on its own once we have discussed the geometric. So good luck with your practicing. Remember, don't think this video is all you have to watch. No. Don't make that mistake. There's many content creators on YouTube on the same topic. Remember, how I teach it may be slightly different to how someone else will teach it. And so you want to get a bit of everything. Put it as a salad. Remember, salad is so nice, but there's oranges in there, there's apples in there, there's lettuce in there. bananas, there's chicken breast in there, a whole lot of things. So make it a bit of a salad, if you ask me. What your teacher teaches you, remember they have a limited time there, maybe at best 45 minutes to teach you anything. And you can see, guys, to just deal with just a component of sequences and series, I took an hour 40 minutes. So imagine the time that you need to actually go through a particular topic would be almost 3 hours. And this is your teacher doing all the work, not you getting engaged and involved. So be very careful, guys. So this is how this should go. I mean, this is the work you would be taught over 2-3 days. I'm giving it to you in just a matter of hours, provided we focus. I mean, this is not different, because if you add the hours for these lectures or classes you would have to attend at school, they would sum up to the same amount of time. So it's either you want this split into days or you want to learn it now. But for me, learn it now like this, so that as you progress in your school over a number of days on this, you are good to go. You probably have gone past this anyway. But for those who want a crash course, this is it. And I hope you guys have enjoyed and will essentially love what we have done. What I'm going to do in the description of this video, I will attach this document there for you to download. This is just for you to enjoy and play with. And of course, you can expand on this by doing as many examples in your textbooks, in your study guides, and do take some past exam question papers so that you have a complete picture of how far you need to go with this topic to get to the end, and make sure that by the time you write your term 1 exams, you are fitter and the fittest student. Because remember, guys, if you score a distinction now, which is very easy in term 1, and you score a distinction in term 2, which is a bit difficult, because remember, term 1 work carries over to term 2, but the level at which it is carried over is usually the most challenging. So for me, I would tell you now, term 1 exams are usually straightforward and very easy, but grade 11 work is usually asked in a very tough way. For example, the quadratic sequence, expect some difficultish questions on that, because you've already done it in grade 11. Arithmetic sequence, already you've done it in grade 11 as well, even as far back as grade 10. Maybe some questions there, but I mean, there's not so much you can ask on the arithmetic. But be very careful. Some questions there can be a bit challenging. But I doubt if you've done the sigma notation as yet. Maybe questions on the sigma notation may be very simple and straightforward. But yeah, the exam can be naughty though. Be very careful. Algebra is always part of it. So that's easy. I've given you some crash course on that. And please remember functions. As you could see, the sum of an arithmetic series, it can be described generally by a quadratic formula or a quadratic equation of some sort, or a quadratic pattern. You know, remember those kinds of things. These are things no one is going to tell you, but you have to see for yourself and make sure you master. All right, guys, let's not prolong this. Leave a like. You may consider subscribing if you think you want more, because there's more in the channel for you, from full papers to some focused questions, and now some little bit of topics to just show you how best to learn a subject or a topic. You first explore what you could do if you didn't have anything at all. Then you start to see when you use what you have and actually start to appreciate that what you did not have, you could actually get to by using whatever tricks and technique that you could play around with and see if it works. And then you start to put the structure into practice, because that's the whole idea. We don't just learn to reproduce, we learn to apply later on so that we can solve much bigger problems than just this academic exercise. All right, guys, I'll see you again next time. Goodbye.